Hi everyone, thank you for watching the video. In this video, I am going to talk to my friend and ask about data science. This might clarify most of your questions about data science. Hi Raj, I keep hearing about data science and how it is used in companies, especially for cloud infrastructure, but I really don't understand it fully. Can you explain it to me in simple terms?
Sure, Kamal. Data science is basically a structured way to make sense of large amounts of data and help companies make better decisions. Let's start with a real life example. Imagine a company running its applications on AWS, Azure, and some on premises servers. Every day, the system generates hundreds or even thousands of alerts. Many of these alerts are false alarms, and resolving them manually takes a lot of time and costs a lot of money.
So the main problem is that there are too many alerts and too much manual work, which is expensive.
Exactly. This is where data science comes in. The first stage in the data science lifecycle is problem identification. In this stage, we understand exactly what the business problem is. For example, here the problem is too many false alerts in cloud infrastructure, high operational costs, and slow response times. We define what success looks like reducing false alerts by a certain percentage or resolving incidents faster. Roles involved here are business analysts and data scientists who help understand the problem clearly. Once we know the problem, the next step is data collection. Here we gather data from all relevant sources. In cloud infrastructure, that could be logs from AWS CloudWatch, Azure Monitor, on-premises servers, databases, applications, or network devices. All this data is brought to a centralized location, like a data lake, Splunk, or Azure Log Analytics workspace, so it can be analyzed together. Data engineers usually handle this stage. Tools used can include SQL, Python scripts, cloud storage services, or ETL pipelines that move data from one place to another. After collecting the data, we need to clean and pre-process it. Raw data is often messy. Some information may be missing, duplicated, or inconsistent. Cleaning makes the data accurate and usable for analysis. This involves removing duplicates, filling missing values, standardizing formats, and sometimes transforming data into a suitable structure. Tools used here are Python with pandas and NumPy, SQL, or KQL. Roles involved are data engineers and data analysts.
Okay, I think I understand. So after cleaning, we can actually look at the data, right?
Exactly. The next stage is exploratory data analysis or EDA. Here we try to understand what the data is telling us. We look for patterns, trends, or unusual behavior. Visualization is very important in this stage. Tools like Power BI, Tableau, Matplotlib, or Seaborn are used to create graphs, charts, and dashboards. Data analysts play a big role here because they translate raw numbers into insights that everyone can understand. For example, we might see that certain types of alerts happen more frequently on a specific server or time of day.
So visualization helps in understanding the problem better and spotting patterns we couldn't see before.
Exactly. After understanding the data, we move to feature engineering. In this stage, we create or select the important variables, also called features, that will help our machine learning models make predictions. For example, in cloud alerts, a feature could be the time of day, type of server, or frequency of previous alerts. Creating the right features is very important because the accuracy of the model depends on them. Tools used here include Python, scikit-learn, or R, and roles involved are data scientists and machine learning engineers.
I see. And then we actually build the model.
Yes, that's the modeling or machine learning stage. Here we apply algorithms to predict outcomes or classify data. In our example, the model might learn to predict which alerts are real incidents and which are false. Techniques include regression, classification, clustering, or prediction models. Roles here are machine learning engineers and AI specialists. Tools used include Python with scikit-learn, TensorFlow, PyTorch, and sometimes AR.
Once the model is trained, what do we do next?
Next comes model evaluation and validation. We test the model to see how accurate it is. We use metrics like accuracy, precision, recall, or F1 score to understand how well it predicts incidents. Sometimes we try multiple models and choose the best one. Data scientists and ML engineers lead this stage.
And after evaluation, I assume we deploy the model?
Correct. That's the deployment and monitoring stage. The model is put into production so it can automatically predict alerts in real time. It also needs to be continuously monitored to make sure it performs accurately over time. Tools used here include Azure Machine Learning, AWS SageMaker, MLflow, and MLOps frameworks. Roles involved are machine learning ops engineers and AI specialists.
Once deployed, how do we use the model for actual decisions?
That's where insights and decision making comes in. The predictions from the model are converted into actionable insights. Dashboards or reports show which alerts need attention and which can be ignored. Data analysts, data scientists, and ML ops engineers work together here. Finally, we have maintenance and continuous improvement. Models are not perfect forever. As new data comes in, they need to be retrained and optimized to stay accurate. This ensures the system continues to provide value over time. So the full data science lifecycle goes like this: problem identification, data collection, data cleaning and pre-processing, exploratory data analysis and visualization, feature engineering, modeling, model evaluation, deployment and monitoring, insights and decision making, and maintenance and continuous improvement.
Wow, Raj, it has a lot of steps, tools, and roles to keep track of. I didn't realize that solving a single problem like cloud alerts could involve so many stages and different kinds of experts. It's like a whole ecosystem working together: data engineers, analysts, machine learning engineers, MLOps specialists, and AI experts, all contributing at different points. Honestly, it seems really complex, and I wonder how someone even starts learning all this.
It can seem overwhelming at first, but nothing is impossible. With the right guidance, dedication, and a structured learning, anyone can understand the full life cycle. Once you know the stages, roles, and tools, it becomes much easier to see how data science solves real business problems.
Thank you, Raj, and thank you everyone for watching. If you have any queries, please reach out to us on WhatsApp or email, or put your questions in the comments section.